Hey everybody, amprepairguy.com, 203-892-4119. Also, harbachellectronics.com. Please like, share, and subscribe. So first off, I'll say it again. This is a personal project. I'm doing it for the fun of it. Eventually I'll offer some 80 through 10 meter versions, but you know, new cabinet and everything. I'm just using parts I have around the shop. I've had to buy some things. Jim donated the electrolytics. So it's just a fun project. Might not even use it. I mean, I'm going to fire it up into a dummy load. I have a lot of amplifiers here that I just don't use. I don't know, I'm weird like that. Some people like collecting cars. But yeah, a few people have asked if I want to sell this. No, it's not for sale. So, okay. So this part is done. I just have to do the testing. I just need to wind the safety choke for the output network in the, for the RF deck, and then I can start testing everything. I need to buy the cabling for the supercon connectors and the twist lock plug. This twist lock plug does not power the plate. It powers everything else. Everything runs on 240. Nothing in here requires a neutral. So I'm going to go over everything, or a lot of it, I guess. I'm going to have to draw it all out. I'm going to make a drawing, schematic, whatever, and parts list, just so down the road, if something happened to me, or if I did sell it when I'm older, someone else can service it. It's pretty simple, but just make it a lot easier on someone else. Plus then I can explain the whole process of from flipping the switch on to everything coming on and everything in between. Okay, so someone said, why didn't I use a big Hubble plug? So these supercon connectors. A big Hubble plug would be huge and it wouldn't fit. It'd be too deep, and they're about 500, 400 bucks or so for each half. I mean, they're crazy money, and it just wouldn't work. These supercon connectors, they're awesome. I've been using them for about 20 years now. And if you look around on eBay, just put a saved search on there. You get these for like 20 bucks each, real cheap. Some people that want crazy money. Same with these. These are the 100 amp ones. I have a box of these, boxes of these. These fuse caps aren't in, but just tons of all this stuff, you know. So I just used what I had. They're all brand new. These ones are available on the Hardbox site. I think, yeah, these ones are also. I'm not sure if I have this one on there. So, yes, someone else said something about labeling things. Yes, I am going to label everything with a label maker. I'll get rid of the permanent marker and I'll label everything. So these are the main line fuses for everything other than the plate. Here's the soft start fuse in series with the resistors. So if a resistor ever went open, I mean if the soft start delay didn't work properly, it would open up the fuse, not blow the resistor. And if the resistor did went, there's an interlock to stop the soft start cycle from completing, you know, the next time around, just so there wouldn't be a massive surge and it blowing up all sorts of stuff with the amount of capacitance in here. A couple of fuses I'll play first. So I got the filament transformer, and I can adjust the primary with the Variac to fine tune it. Oh, I'll be right back. I need to make more room on here. So right back. Sorry about that. So yes, so I can adjust the primary. I'm going to put a knob on here. Be like set and forget, so I don't have to. It doesn't have to be in the front or anything. I wanted the front to be nice and clean. The connection for the pressure interlock. So again, I'll explain that. So if the filament were to, if the blower were to fail, it won't allow the amp to continue running or come on. So basically, there's a pressure switch. Once it senses there's pressure in the bottom compartment of the RF deck, it allows the power on cycle to start, or if it's already running, it shuts it all down. Have the series glitch resistors. These are 50 ohms. They're wired, so I have 50 ohms at X amount of wattage. I forget what they're rated for, but they'll handle the full plate ampacity at 100% duty cycle. Here's the fuse in series with the B positive. Okay, the reverse connected diodes, 3 per leg. Clamp the B negative if there's ever a short in the B positive. The dropping resistor for the meter up on the top, and resistor on the cold end going to the B negative. So you know, when I have the multimeter switch on another setting, I don't have the full B positive up at the multimeter switch. Very important. They do the same thing in Drakes and other amps. Okay, so this lamp right here, an idea Jim gave me, put it on the back, so I don't need it on the front. If this fuse were to open up, the meter on the RF deck is going to go to 0, the high voltage meter. This is connected to the very last cap, the B negative side. You know, here's the positive side, you know, very first, and then here positive, negative. They're all on a string, all in series. So basically, it'll tell me that the cap is charged. Caps are still charged. So I used a piece of copper strip, punched a hole in it, and I soldered. First I attached that little ceramic standoff, very slick, huh? With a number 4 screw going through the copper strip. And the copper strip is soldered to that standoff that's just used for the mounting of the cap. It's not electrically connected to anything, you know, not the can and not the other terminals, obviously. And I have the proper dropping resistor. Okay, so once I get down to a certain voltage, when it starts to bleed down, the lamp will go out. But I still would never go in here assuming, just never assume with high voltage. I'd still go in here with a chicken stick or whatever you want to call it, Jesus stick, and have a resistor in series and go cap, 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 cap. And then still, after that, I would go in there and short each one. You never want to just go in and short caps, put a hard short on an electrolytic cap, because you can damage the capacitor. And if you don't have reverse connected diodes, you'll take out the plate current meter. Okay, so I changed the capacitor on the soft start board, so now it'll delay it for 10 seconds versus 1 second. This whole assembly came out. I designed it that way so it could easily come out. 4 screws. Now it's fully secured. Comes unplugged. That board comes unplugged. So that's all set. Everything's wired. So someone says something about why did you use wood? This is my own amp. Okay, this will never get wet. It's going to stay nice and toasty in here. They used to make TVs with wood, all sorts of stuff. So everyone loves to think of something. You know, old radios, they used wood. But these caps are not touching the wood. As you can see, there's a gap. Take a piece of wire. You see how the wire's slipping under there? Not touching. And the screws don't go all the way through. There's no way that it would flash. Not going to happen. If this were a customer's amp, then yeah, I would get a piece of acrylic material and probably drill it, tap it, and all that kind of stuff. But if we're going to use caps like this, the only reason I'm using a bunch of electrolytics is because I can't fit a big oil cap in here. So this was the next best thing. But this is a lot of capacitance, so you have to have a good series glitch and then the fuse. And I have the other fuse in series with one of the plate secondaries. So, so I reused this rectifier assembly as a full wave bridge rectifier. Again, it's not touching. It has nylon standoffs between the board and then this fiberglass material down here. And that is not going anywhere. So, see, I've been doing this a long time. So there are diodes on either side of the board. So 4 legs. More than ample. So that's all set. Reuse this. I have 3 of these. Just great. I've been doing this a long time, so I planned everything out in my head before I drilled my first hole here. But I got everything to fit. And if you look at my other videos, you'll see the blower hangs down from the cover. And it's going to pull a ton of air through. There's a filter in the front here. It's going to pull all that air through, past the resistors, past the capacitors, and this is going to get blasted with air, so it's going to stay nice and cool. Okay, so something else cool here. I added a thermal switch. So I think it was like 90. I forget what it was. I think it's like 90 Fahrenheit. But it's below the max temp rating for the tube, so I was going to set it up so it shut it all down, but because there's headroom, what it will do is open the key line. So this is normally closed, and I used more of these little standoffs, which are really cool. I got like bags of them. And you can get these on eBay. If you're willing to wait and get them in groups of 6 or 7 from China for $1 or something, but I wanted it quicker, so I bought one for $7. So normally closed. They also have them in normally open. They have all sorts of different temperature options. And yeah, it's just in series with the key line, which is low current. Well, actually, the key line doesn't even switch the relays. It's switching that right there. So it's basically a soft start. Okay. So I got the diodes across each cap. People say, well, why'd you do that? You know, these are 100K 1% 3-watt resistors. They're not cheap. So, okay, to answer your question about the diodes, these are very expensive capacitors, okay? If one of these diode strings were to short, which, I mean, everything's protected so well, I seriously doubt it's going to happen, but if it did, you'd end up pumping raw AC into the caps, and the fuse in the transformer cabinet should pop, but before it pops, it should pop pretty quick, because you'd be, you know, you could end up damaging it otherwise. That's unlikely, but it could happen. You'd be pumping raw AC into the caps, which could destroy or damage the capacitors. So these would just end up shorting. Cheap. These are cheap to replace versus changing, purchasing and then changing the capacitors. I have another video talking about the ratings of these caps, the amount of current that they're rated for is like, I think it's like 9 amps or something, so they will have a nice easy life in here. Do the math on everything. These are 2500 microfarads, 450 volts, 95C. So they will never, ever, ever be at their temp rating. They're going to last, they should last longer than me, hopefully. So this thing, like I said, it's all set. I just got to start the testing, but that's going to be over the winter. I used mercury contactor. Someone made a comment, oh, what if they blow up? You know, it's like there's always someone that has to make some sort of comment. They can't say, oh, it looks cool or whatever. And, you know, they've probably never even made an amp before. If they have, maybe it's just a monoband amp. But, you know, let me remind people, Henry Radio used mercury contactors in all of their console amplifiers. The guy who made amps in California, he just retired, he used them. Henry used them in their commercial amplifiers, their RF generators, their everything. So, except for their desktop units. They're used in large 3-phase ovens, all sorts of stuff. So these would never be pulse switching or anything real fast. I've never had a problem. Every single amp I've built ever, I've had mercury contactors in them. So problem is, with a regular contactor, the contacts end up pitting over time, even with a soft start. So Jim did the math. It's going to pull about 20 amps for a split second. So that first contactor, when it, if you had a standard one, there's going to be a little tiny arc, and it's going to eventually pit and fail, or even stick. So this is the way to go. These are brand new. You can get these on eBay, dirt cheap. You just got to look around. I like buying cheap. I just wait. Best time to buy something is when you do not need it. Period. So I'm really fussy about zip tying even my personal stuff, and when I make something for someone, it's even prettier. My phone keeps going off. I didn't go real crazy with replacing the wires to the Amphenol plug. I just soldered and heat shrunk connections to existing wires. Again, this is for fun. This isn't for hire. And even doing certain things I've done, taking shortcuts, it's still so much time. I'm not getting paid for this, and I don't really have the motivation to do this other than just it being fun. I won't do it again. That's why I'm not going to sell it. I'm never doing this again for myself. It's just too much work. I work in amps all day, every day, during the week, and it sucks the fun out of it. I'm sorry. But, so, that's about it for now. I mean, I have a huge box of these relays. They all have a 240 volt coil, so they're part of all the interlocks and the stages to... I mean, I tried to think of anything and everything to protect things, because this thing won't, if I use it, it's not going to be near me. It's going to be in the other room, out of sight, out of mind. And when you have something like that where you can't see it, I mean, I guess you could put a camera on it, but you don't want to have to worry about something lighting on fire. And you know, tubes, they aren't cheap nowadays. A lot of the parts, just the price of everything nowadays is crazy. You know, so I want to protect the tube. I want to protect other things as well as I can. And yeah, so, but I put heat shrink over the braided material to help protect it. This is getting a ring terminal. It'll be grounded to the transformer cabinet like I said before, and these will get ring terminals and will connect to the standoffs in the power supply cabinet. So, this is a ring terminal on this side, which is grounded to this cabinet. So they'll be bonded together. I have some of these, not many extras. I do have a whole bunch of the 200 ohm version. This was more than ample. There's big and then there's stupid big. I mean, in my big Tetra I have here, that I don't use a name. I don't use. That has the 18-inch long ones that are 200 ohms each, so they're 4 in parallel. You know, something like that. You need them, but this is more than is what needed, and they fit. And it's just getting everything to fit and reusing the circuitry was just, it required some thought, you know, and Jim helped me with a few calculations on things. But it was just a major challenge to get everything to fit and, you know, all the proper parts to fit. And there was no guessing. Everything was calculated. So it should be one and done. So I'm going to have to bring the plate up slowly. We'll test the soft start, make sure it's operating properly, then bring the plate up, bypass the soft start, bring the plate up, and condition the caps. They're old stock, and then make sure everything is correct. You don't just flip a switch and cross your fingers, because that could be bad, you know. One of these failed, it'd be kind of scary, you know. So, I don't know if you've ever heard knock on wood, I've never had it happen in anything I've made, but to have a diode string fail, I've heard stories, you know, that sounds like a M80 going off, and at least the thing, I mean, when you're right near it and something like that happens, I can only imagine how scary it is. So, I've heard stories of people won't even turn something on with their finger. They put headphones on and they use a piece of wood, and you know, off, you know, you know, a few feet away from it, you know, but yeah, so I adapted the transformer to fit with the stock holes. This is where the plate transformer used to be here. So yeah, just a lot of thought. I have the bat rocker switch that goes through the front. So I put another reason why I put this back here, I just want the front to be clean, and you know, if I had to, I want to be able to remove the front panel. So I can take the nut off the bat switch. It goes through the frame of the cabinet and then also through the front panel. I can take the nut off, and then there's screws that hold that on. I have to take it off anyway to repaint it to match the RF deck front panel. I'm going to use the appliance paint from Home Depot like I did before. But I don't need to look at this all the time. I can just, for once in a while, make sure it's still working, and yeah, just check the back out. But again, everything's going to be labeled. Okay, so that's about it. I hope everyone is enjoying this, but this half is done. The other one's done minus the safety choke, and I'll just have to start doing testing, but I need to get my line voltage issue resolved. Hopefully, I don't know if that's going to happen this winter. Might be, I may have to wait till spring. My drop is like 250 feet from the transformer. It's just crazy long, and I'm going to have to... I already talked to my guy. They're going to put a whatever size transformer I want near the house, but I have to put in some gravel, so technical driveway. I have a lot of property here, so I want it on the meter base, close to the meter base side of the house, so it's not a quick thing like the other house. They even said I could get 3-phase here, but that's crazy. It wouldn't be cheap. They said it would, be a bunch. They have 3-phase on the street, so not sure if I'm going to do a 400 amp service, 600 or 1200. It just depends on what my electrician says the materials will cost. That's all I have to pay for. Okay, so again, thank you for watching. Here's the Alden plug. Plugs into this, which bolts up to here. And there's an interlock. So that was already there. And that's in a shielded conduit, which goes up to the RF deck. Okay, so that's it. Gotta get back to work, so I'll catch you later. Have a great day, and TGIF. Hope everyone has a great weekend. 73.